Good afternoon, my dear students. Welcome to one more amazing session from Infinity Land by Sri Chaitanya. मैं हूँ सुरेश, Faculty of Chemistry from Infinity Land. How are you all, my dear students? Good afternoon. Can you please confirm? Are you able to see me? Am I audible and visible? Just give a confirmation. That's good. And welcome to NEET STEP UP 2025 program. In this program, Infinity Learn is offering physics, chemistry, biology, NEET sessions right from 12 o'clock to evening 6 o'clock, and you all use these sessions and get benefit of it, and you like these sessions and share with your friends so that they are also getting benefit of that, and subscribe to the NEET channel by Infinity Lane. How are you, my dear students? Good afternoon again. And today we are discussing about chemical equilibrium. In this chemical equilibrium, yesterday we started all the rate, instantaneous rate and average rate and law of mass action, law of chemical equilibrium, Kc, Kp, and the relation between Kc and Kp, and many more things we had. And in today's session, we are going to discuss about application of Kc and Kp in various reactions and Chatelier principle, and थोड़ा सा बचा हुआ and इससे हम कर सकते हैं कुछ क्वेश्चंस भी है केमिकल इक्विलिब्रियम, श्योर शॉर्ट क्वेश्चंस नीट एग्जामिनेशन में आप पकड़ने वाला है. Okay, so why late? We all ready to do that. Very good. And we are waiting for those many students who are actually regularly attending. So meanwhile, I just want to take you what Infinity Learn is doing for the NEET students. Yes, that is, we are doing an awesome picture about results. Result can speak a lot, and in the channel you can all see my dear students. Yes, in this YouTube session that's going live right now, and on the description box you can see, on the description box you just click more over here. On that you will be getting the first link that is given here. Yes, boost your NEET score with Infinity Learn, and a link is given to you, and with this link you just click it so that you will be directed to one more page where you are going to see many features of here. Yes, Amir, good afternoon. Anamani, good afternoon. Say hello, hi, thank you very much. Yes, my code is already recorded there, right? And in that you can see, many students are there. Not only these 4 students that are presented here. Ashrita, she got 330 score in 2023, but she secured 2024, and 2024 she secured 650 plus, and there is a 350 plus score increment is given. So not only those students, but also many students are there. You can see Ashrita, Akhil Verma, and Satyanarayan and Hema Dyuti, and these students are securing the more than 350, and you will be the next for the 2025 score, right? And these people attended the Infinity Learn program, rank guarantee program, and the key features in this rank program you can see: comprehensive video lectures, personalized learning, detailed study materials, performance benchmarking, and efficient revision tools, expert doubt resolution, and ultimate practice test. And also you will be going to get Achiever series books to your doorstep. So here you can see here. So there is a program, NEET 2025 rank assurance program. The batch starts from 16th of August for NEET droppers, and these sessions are given by eminent faculties, and these are the faculties including me, and there you can see 480 hours plus a live class with complete NEET syllabus, and downloadable notes, class recordings and DPPs, and 5,000 topic wise recorded videos by India's top level faculties, and chapter wise previous year questions along with video solutions, and full syllabus mock test with a detailed report, and weekend test series along with rank analysis and 24/7 doubt resolution at any question. So when you have a doubt at any moment, any day or night, wherever you want, you can get the doubt resolved at that moment. And 30 NEET Achiever series printed books, and it will be reaching to your doorstep, and parent mentor teaching with progression of the discussion. And you see, in 2024 examinations, there are 9 students who got 720 out of 720 from the Infinity Learn NEET Rank Assurance Program, and that is the statistics for 2024, and you are preparing for 2025. So with these features, these statistics will be for you, and you will be in this agenda. Right now, there are 45 students below 100 All India Open Category ranks, and 130 students scored 700 plus, and you can get it. So how to enroll this? So again we go back to the same page. In the same page, you can see so many courses are disclosed over there in that so many pages, and you are going to see upcoming schedules and enroll now. In that enrollment program, you can see a particular program there. When you click it, buy now, when you click it, you will be directing to the payment page, and verify your phone number, then you go for the payment. Before going for the payment, I just want to show you there is an amazing slide that can you the best discount of it, and use Suresh 50 is a coupon code there. Suresh 50 is a coupon code. Please make a note of it. When you enter this Suresh 50 coupon code, and the price is going to be slashed 20% flat, then you can go for the payment gateway either by using UPI and credit card or net banking, and you can enroll the session, so that you are going to experience awesome lectures and awesome features from Infinity Land, along with the NEET 2025 rank assurance program, and definitely I can assure you that you will get rank. Hena, are you all ready to do that? Yes. And why not? Without late, we are going into the equilibrium. Are you ready? I shall Amir, Anamani, okay, and boost your NEET score with Infinity Learn. Enroll now, and you just one click away to go into the excellent academic journey from Infinity Land, right? Okay. So with this chemical equilibrium, what factors affecting equilibrium constant? So equilibrium constant, it is given as when A plus B gives rise C plus D, the equilibrium constant Kc is given as C D upon A B enclosed in the square brackets, and the square brackets includes the active masses. So you can also say Kp expression like that. Kp expression is going to be partial pressure of A dot partial pressure of C dot partial pressure of D upon partial pressure of A dot partial pressure of B. And if this reaction is reversed, the reaction is given in this way: A plus B gives rise C plus D. Pradeep, hi, good afternoon. If the reaction is reversed, and Kc dash is going to be A B upon C and D, and ये दोनों का relation होता है क्या? So ये fraction ये उल्टा करने तक ये मिलेगा ना, इसी का कारण Kc is equal to Kc dash. So what I mean to say, when the reaction is reversed, the Kc is going to be inverted. Mind it, it's very important. Based on that, you can get a NEET examination question. Right, my dear students? Okay. So Pradeep Kanthekar, good afternoon. And Ishita is there in the class. Abhinav. Okay. Logavanayam should be there. He is having a school. He said the other day. Okay, let's go ahead, and the mode of representation of the reaction, direction of the reaction, equilibrium constant badalte rehte. Yes, and one more important thing, for example, nitrogen plus hydrogen gives rise ammonia. अगर मान लो Kc 5 होगा तो ये reverse reaction का Kc कैसा कर सकते हैं? That is going to be reversed, and it is inverted is going to be 0.2. Like that, a concept along with a question is done in this particular session for every session, so that you just don't miss these sessions, attend the sessions regularly without fail, and you can really enjoy the awesome lectures from Infinity Learn, right? So what late, we should go ahead. And if the stoichiometry of the reaction is changed, rate constant or equilibrium constant Kc is going to be changed. Let us say NO2 plus NO2 gives rise N2 plus O2. For this reaction, Kc is going to be N2 dot O2 square upon NO2 square. If you take the reaction is divided by 2, so that NO2 gives rise half N2 plus O2. So इसका Kc होगा Kc dash is equal to N2 power half dot O2 upon NO2. So ये दोनों का क्या, अगर ये स्क्वायर करने तो ये मिलेंगे ना, so that Kc dash is equal to square unit of Kc, square root of Kc. Like that, you can have n number of examples with that. Okay, so the rate constants Kc dash is equal to root Kc is one parameter. Hello. Next, let us talk about one more 1/2 equation, dependence of the temperature. In the dependence of the temperature, as temperature increases, rate constant increases, equilibrium constant is also increases in general. It all depends upon whether the reaction is exothermic and endothermic. Okay, so for this 1/2 equation, मान लो K1 is the equilibrium constant at temperature T1 and K2 is the temperature, K2 is the equilibrium constant at temperature T2. How K1 and K2 and T1 and T2 are related with respect to the enthalpy of reaction, that is given as a delta H. So log K2 by K1 is equal to minus delta H by 2.303, R is a gas constant of 1 by T2 minus 1 by T1. This is what you call it as 1/2 equation. हर फॉर्मूला इम्पॉर्टेंट है, हर फॉर्मूला इम्पॉर्टेंट है हमारा क्लास में. सो मान लो एक बहुत इम्पॉर्टेंट का चीज है, एंड दिस इज अ फॉर्मूला यू कैन हैव इन द formula sheet, and you can get this recalling of the formulas during physical chemistry sessions are very important. Okay, everybody make a note of it. And also we can have if delta H is going to be 0, that is what you call it as thermoneutral reaction. So the delta H, enthalpy of a reaction, is 0, which means that neither heat is absorbed nor evolved. In that case, if the temperature is increased or temperature is decreased, there is no change in the equilibrium constant. So log K2 minus K1 is going to be 0, log K1 is equal to K2, K1 become equal to K2. So thus equilibrium constant remains the same at all temperature if the temperature T2 is higher than T1, and if 1 by T2 minus 1 by T1 is less than 0, log K2 minus K1 is equal to negative delta H by 2.303 R. Okay. Next, if the reaction is endothermic, heat is going in, so log K2 minus K1 is greater than 0 and K2 is going to be greater than K1. The value of the equilibrium constant is higher at higher temperature. So the same logic we can use in Le Chatelier principle. So for endothermic reaction, अगर टेम्परेचर बढ़ेंगे तो इक्विलिब्रियम कांस्टेंट बढ़ते जाएगा, रिएक्शन फेवर्स इन द फॉरवर्ड डायरेक्शन. गॉट इट? दैट्स फाइन, वेरी नाइस. एंड व्हेन डेल्टा H इज नेगेटिव, ये एक्सोथर्मिक होगा, ये वाला एक्सोथर्मिक जिस रिएक्शन में हीट इज रिलीज्ड आउट इज कॉल्ड एज एक्सोथर्मिक. सो फॉर दैट log K2 minus K1 ये 0 का कम आना है, so that K2 is less than K1. Yes, right, very good, thank you. And the value of equilibrium constant is lower at high temperature in the case of exothermic reaction. For exothermic reaction, if the heat is released and the product is going to be heat, when the temperature is increased, the reaction favors the backward direction. That's very, very important, and Kc is inversely proportional to 1 by T. And the value of equilibrium constant is independent. मान लो ये independent, ये NEET एग्जामिनेशन में बहुत important चीज़ है, किस किस चीज़ में ये डिपेंड करता है नहीं, and that is about initial concentration. That is about initial concentration. So the equilibrium constant is independent on initial concentration of the reactant, but it is dependent on equilibrium constant, equilibrium concentration. That's good, very nice. And also the presence of catalyst. Catalyst has no influence on the state of equilibrium, also equilibrium constant, है ना? And the catalyst, the direction from which the equilibrium has been achieved or attained, you can say, when you talk about an empty vessel you take, उसमें हाइड्रोजन इंट्रोड्यूस करो, हाइड्रोजन एंड आयोडीन इंट्रोड्यूस करो, सो दैट H2 प्लस I2 रिएक्ट करके HI बनेगा, सो रिएक्शन फिर वापस आना है. सो द Kc इज सेम. अगर मान लो दूसरे एक्सपेरिमेंट में ये एम्प्टी वेसल में अगर HI इंट्रोड्यूस करो, क्या होगा? HI डिसोसिएट करने के बाद HI dissociated to gives rise H2 plus I2, and इस टेम्परेचर, जब तक टेम्परेचर कांस्टेंट है ये Kc वैल्यू दोनों में सेम होगा, दोनों में सेम होगा. आर यू गेटिंग और नॉट? And it's very, very important, the direction from which the equilibrium has been attained, also initial concentration से, लेकिन but depends on equilibrium concentration. Equilibrium concentration, है ना? And also the presence of inert material, उसमें थोड़ा सा नियॉन गैस और हीलियम गैस इंट्रोड्यूस करो, इक्विलिब्रियम कांस्टेंट का कुछ इफेक्ट नहीं होगा. That's good, fine, okay. What about Ishita? Hi Ray, Uttam Kumar, where is your punch? I still remember Uttam Kumar. Hi, where is your punch? Yeah, I still remember that. When we are having a organic chemistry discussion, you used to be there with a lot of punch, am I right? Yes. Nowadays you are not attending. Why? Your school has started? And tomorrow for you I will make it organic chemistry hour. Ready? Are you ready for that? So tomorrow we are going to discuss about hydrocarbons NEET questions. है ना? Very good. So let's talk something more about it. Yes, that's good. Try to be regular in the class, Uttam. And you can see a question. Are you ready to do this? E plus F reversibly gives rise G and H. If we start with 6 mole of E and 7 mole of F, and in a 1 liter vessel, when the equilibrium is attained, 4.5 mole of G is formed. Calculate the value of equilibrium constant for the reaction. Who can do this? Uttam, ready to do that? So in today's class, mostly we are focusing on the concept as well as more questions. NEET sure shot questions. Get ready for that. NEET sure shot questions. Uttam, so you can attempt this question. If E plus F gives rise G plus H, initially when E plus F gives rise G plus H, इसका 6 होगा and 7 होगा, कुछ नहीं है, and it is little clumsy. Let me write here. E plus F reversibly gives rise G plus H, and initially 6 mole of this and 7 mole of this are taken when time is equal to 0. When the time reaches to equilibrium, so 6 minus कुछ react होगा, 7 minus कुछ react होगा, है ना? लेकिन 4.5 moles of this G is formed, so that जितना G form होगा and उतना ही H form होगा 4.5. अरे जितना G form होगा उतना E कम होगा and 6 minus 4.5. So 6 7 minus 4.5. सो अगर ये 7 माइनस 4.5 आएगा तो आपका कितना होगा, ये कितना होगा. सो यू आर गोइंग टू लेफ्ट विथ 1.5 एंड इट इज गोइंग टू बी 2.5. नाउ हर चीज 1 लीटर कंटेनर में है. Kc का जो एक्सप्रेशन है दैट इज गिवन एज G एंड H एंड E एंड F. सो उसमें G कॉन्सेंट्रेशन 4.5 upon 1 and H concentration 4.5 upon 1 and E concentration 1.5 upon 1 and F concentration 2.5 upon 1. When you solve, so you are going to get 5.4 is the answer. So this rate constant has no unit in this case. हर मोल पर लीटर मोल पर लीटर मोल पर लीटर मोल पर लीटर काटने को this 5.4 has dimensionless है ना. Dimension is also very important. I am going to summarize everything here. That's fine. That's fine. Good. Hope you understand. और एक क्वेश्चन आपका सामने तैयार है. So equilibrium constant Kc for the reaction of H2 plus I2 is going to be 57 at 700 Kelvin, and this is the reaction H2 plus I2 gives rise to Hi and Kc is given 50. And if 1 mole of H2 is allowed to convert with 1 mole of I2 in 10 liter vessel at 700 Kelvin, what are the concentrations of H2, I2 and Hi at equilibrium, and what is the composition of the equilibrium in moles? So analysis Uttam Kumar, analysis of the equilibrium constant and equilibrium concentrations are very important. If you are able to do that, you can do the best in the NEET examination. It takes very less time to understand and it's very less time to solve it if you go in a logical way, है ना. So we can do this. What late? We can do this. Yes. What is the answer? You solve it and tell me. Otherwise, I am going to solve it, Uttam Kumar. Shall I solve it or you want me to solve? Okay, I will solve it. Here you can see when you want to solve it, my dear students, this is the steps you need to follow. Step 1, write the balanced equation, right? And step 2, under balanced equation you need to follow A and the B and the C steps. You write the initial concentrations and the change in the concentration on going equilibrium and equilibrium concentrations. Let us say H2 plus I2 gives rise to Hi. So when time is equal to 0, you can say let A moles are taken and B moles are taken and 0. When the time is going to be equilibrium, let X amount is consumed, it is going to be A minus X, B minus X, and it is going to be 2x. So the Kc is written as Hi square H2 dot I2, and the concentration of Hi is equal to, let us say, in the V liters of the vessel. So that Kc is written as Hi, so that is going to be 2x by V whole square upon A minus X by V dot B minus X by V. So like that you need to do, that is the steps I have given. Substitute the equilibrium concentrations and you can solve it at step 3. Calculate the equilibrium concentration for the calculated value of X. You have to evaluate the X. and check your results by submitting them into the equilibrium equation. So the step 1, 2, 3, 4, 5, and you need to follow the same sequence when you solve any level of questions. So I have given you the method, am I right? I have given you the method. Follow this. Uttam, fine. Uttam, fine. That's good. And where is your punch, Uttam? I want to see you. Thanos hand. Na? Thanos hand. Show me your Thanos hand. Uttam. Okay, let us solve the previous question based on this steps. You can see H2 plus I2 to gives rise HI. Initially 0.1 लिए थे and H2 I2 भी point, yes it's clear 0.1 लिए थे and HI के concentration initial में शुरुआत में कुछ नहीं है and at change in the concentration at equilibrium 1 mole and 1 mole and it is 2 mole, so 1 and 1 and 2, so 2 becomes 2x is formed and 1x is removed and 1x is removed, so that 0.1 minus x, 0.1 minus x, it is going to be 2x. That is the actual analysis and Kc is going to be 57 de chuka and Hi square upon H2 plus dot I2, so 2x square upon 0.1 minus x dot 0.1 minus x is equal to 2x upon 0.1 minus x whole square. On solving, so you are going to get root 57 is equal to x upon 0.1 minus x. So on solving, x हमको मिलेगा 0.079 molar. So take that x value and you can use that 2x equal to that x is going to be 0.136 molar is the concentration that is consumed. Okay. And also calculate the equilibrium concentration from the calculated value of x, that is the fifth step, है ना? Yes it is. And H2 and I2 दोनों का concentration बराबर है 0.1 minus x होगा 0.1 minus 0.0791 approximated to 0.08 कुछ नहीं पूछेगा, so आपका 0.02 होगा, है ना? Right. And check the results by substituting in the Kc value, you are going to get. So अब जो भी x value calculate किया यहाँ पर आपका बराबर देख रहे हैं, so फिलहाल आप जो किया वो सही है. Understand or not? Don't worry, this calculation है ना, यहाँ पर थोड़ा सा दिक्कत होगा, आपका बेसिक मैथ में स्ट्रांग होना चाहिए क्योंकि जो भी क्वेश्चंस इक्विलिब्रियम एंड केमिकल काइनेटिक्स एंड थर्मोडायनेमिक्स में करने के लिए थोड़ा सा स्कूल लेवल मैथमेटिक्स इस्तेमाल करके आप एक्स निकालना, सिंपल अलजेब्रा क्वाड्रेटिक इक्वेशंस भी जानकारी पढ़ना पड़ता है. ओके, नाउ and the number of moles of each substrate can be calculated by extracting the expressions by putting the value of x, so that you are going to get moles of Hi and moles of I2 is going to be 0.21 and moles of Hi is going to be 1.58 at equilibrium, है ना बेटा? And this is the exclusive model that I want to give you for, you can use the same method, you learn method, don't go for blindly with number of questions, go for the methods and you can do the best in the NEET examination. इतना लंबा नहीं होगा ये क्वेश्चन में, ये छोटा से पार्ट से NEET examination में क्वेश्चन आने का संभावना है. My dear students, you can go with one more example. आप करेंगे? Yes, आप करेंगे, मैं करना है. ये क्वेश्चन जल्दी बताओ. And this question says 0.5 mole of H2 and 0.5 mole of I2 react in a 200 liter vessel at 448 degrees centigrade and the equilibrium constant Kc is 50 and what is the Kp value? Calculate the mole of iodine at this equilibrium. Rehan Rajputra. Yeah, exclusive method तो yes, बहुत लेंदी नहीं है बेटा, ये बहुत लेंदी से हर कॉर्नर से एक ही क्वेश्चन होगा. जो प्रीवियस क्वेश्चन है ना उसमें 5 क्वेश्चन निकाल सकते हैं. गेटिंग और नॉट रेहान राजपुत्रा? यस इट इज. सो You all go with YouTube channel and subscribe to that, so that you are going to get the seamless exclusive lessons from Infinity Land. Yes, it is. Okay, आप करो, मैं करना है क्या, जल्दी बताओ. Getting it? Yes, it is simple. Kc Kp का रिलेशन क्या होगा? Kp is equal to Kc RT to the bar delta n. Remember, what is delta n there? What is delta n there? Delta n gives you the number of gases products minus number of gases reactants. It is very simple. Okay. So for this reaction, delta n is equal to 0, so that Kp is going to be Kc here. Now H2 plus I2 gives rise to Hi, and initially शुरुआत से 0.5 लिया. When T is equal to 0, when T is equal to equilibrium, and I2 is going to be 0.5, Hi is going to be 0. In that 0.5 minus x, मान लो x is consumed, ये भी x consume होगा, ये 2x form होना है. Since delta n is equal to 0, Kp is equal to Kc, so for this reaction we got Kp is equal to Kc, and it is given as, so 50 is given here. Okay, Kc is given as 50, so that Kp भी 50 होगा, and 50 is equal to 4x square upon 0.5 minus x whole square, and it is going to be 2x upon 0.5 minus x is equal to root 50. On solving, so you are going to get x is equal to 0.39. so ये 0.39 ये जो है ना उसमें डालो, आपका H2 concentration निकलेगा, and it is going to be 0.11 है ना. It is very simple, very simple. And also एक्सटेंट ऑफ रिएक्शन एंड इक्विलिब्रियम कांस्टेंट बहुत इंपॉर्टेंट चीज़ का है. ए कॉन्सेप्ट से नीट एग्जामिनेशन में क्वेश्चंस आना है. एंड मोर इज द कॉन्सेंट्रेशन ऑफ द इक्विलिब्रियम कांस्टेंट, एंड रिएक्शन हमेशा आगे बढ़ने का कोशिश करता है. एंड Kc वैल्यू कम होगा तो सो इक्विलिब्रियम पीछे आने का कोशिश करता है, बैकवर्ड रिएक्शन इज फॉरवर्ड. सो and reaction proceeds hardly at time. If the Kc value 10 power minus 3 से कम होगा तो रिएक्शन हमेशा बैकवर्ड करने का कोशिश करता है. अगर Kc वैल्यू 10 क्यूब के ज़्यादा होने तो रिएक्शन proceeds in the forward direction. and also if you have a Kc value दोनों का अंतर में होगा, so that reaction आगे भी जा सकते हैं, पीछे भी वापस आ सकते हैं. So this is the actual physical significance of the Kc. Are you getting or not? Fine, it's very very important slide, and you can see the Kc value in the question itself, and you will be having a rough picture about how the reaction is going to be proceeded. So if the reaction is at equilibrium situation, or always backward situation, or forward situation, that can be explained based on this particular slide. Right beta? Clear? And Uttam Kumar? Very good. Now let us talk about reaction quotient. A reaction quotient क्या? Yes, it is nothing but equilibrium constant. मान लो A moles of A, B moles of B, and gives rise x and y, and at any other than stage of equilibrium. So reaction quotient is given as, it is same just as Kc. Let us say A moles of A, B moles of B reversibly gives rise C moles of C, and D moles of D, है ना. And Qc is equal to same C to the power C, and D to the power D, and A to the power A, and B to the power B. And Kc भी लिख सकते हैं. Kc कैसे लिख सकते हैं? सेम ये दोनों का क्या अंतर है देन? Yes, it is. ये दोनों में क्या अंतर पता चलना पड़ता है. So अगर QC is equal to KC, then the reaction is at equilibrium. अगर KC ज्यादा होगा तो रिएक्शन आगे जाने का कोशिश करता. And Ishita, you are late. Why so? And if QC is greater than KC, then reaction try to come in the backward direction. Fine. So it can go in the forward direction as Kc value is increased. The reaction comes in the backward direction as Qc value is increased. So this is the pictorial representation of Qc and Kc. अगर Kc Qc बराबर देख रहे हैं देखो, then the reactants and the products are present in the equilibrium mixture. अगर Kc value is bigger than Qc value, reactant more converted into the product, so products predominate in the reaction mixture. Whereas Qc बड़ा होगा तो reaction backward बढ़ेगा, so that the reaction is going to favor in the backward direction and it is going to be more reactants are present in the reaction mixture. Yes. And also, so this is the prediction, and based on this prediction you can get a NEET examination directly. Direct questions are there, some questions are there in the NCERT textbook, and you can all just look into that and solve the appropriate corners of the questions. Is very important. Based on this, the total chemical equilibrium, definitely I am going to tell you where the questions can come. Evaluation of Kc and Kp, and direction of prediction of the reaction, QC reaction quotient के हिसाब से. If not, definitely you will be getting a question from Chatelier principle, and if not, vapor density के हिसाब से question भी आ सकते हैं, है ना. You see, when you study a particular lesson or a chapter, you should have what are the actual concepts are present in the questionnaire, and how you are able to solve these questions, and where the question is coming, which area you can get a question. Are you getting or not? Clear? And that's very good. Now Ishita, how are you? Tell me. How are you? You tell me. You came late today? So came late from college or school? Okay, fine. And let's talk about the more details. So immediately concept followed by a question. You all do this question. You all do this question. Can do a mixture of 4.2 moles of nitrogen, 2.0 moles of hydrogen, and 10 moles of ammonia are introduced in 10-liter vessel at 500 Kelvin. At this temperature, the equilibrium constant Kc is given as 1.7 into 10 square. Okay. Now, I am asking for the reaction N2 plus 3H2 plus 2NH3. Is the reaction mixture at equilibrium? That is the first question. If not, what is the direction of the reaction? It is a typical NEET examination question. So, of course, this question is subjective and it can be converted into objective. So, I am extreme. No, I will watch the video again. Okay, yeah. You can do this. Try. Ishita, you can try it. I have seen you are doing awesome in thermodynamics and the chemical equilibrium also you can do it. कर सकते हैं? हाँ. Okay, try to do this. I will check how you are going to give the answer, and you have to calculate the QC at that time. When you calculate QC at that time, आपका पता चलेगा QC KC वैल्यू कंपेयर करके ये इक्विलिब्रियम है नहीं है. सो अगर QC KC वैल्यू का ग्रेटर और लेस देन करके आप बोल सकते हैं रिएक्शन किस डायरेक्शन में जा रहा है ना. सो दिस इज अ टिपिकल नीट लेवल क्वेश्चन. यू ऑल डू दिस. Students, come on. And when you solve it, nitrogen concentration, it is 4.2 in 10 liters. Okay, it is going to be 0.42. Hydrogen concentration 2.0, so the 2.0 upon 10, 0.2, and ammonia concentration it is given as 10 moles per liter is active mass, is going to be 10, 0.1. Now let us solve this in the QC. The QC value is given as NH3 square upon N2 plus H2 cube, right? So that 0.1 square upon 0.42 upon 0.2 cube, and it is going to be 2.976. and ये value को compare करो, of course it is given as 10 square, यह बहुत कम है. So since Kc is 1.7 into 10 square, since the Qc is not equal to Kc, Kc ये ज़्यादा है, so reaction हमेशा goes from the left to right, reaction आगे बढ़ता है. Okay, so this is the prediction of the direction of the reaction. Are you getting or not? Clear? Fine. Is a typical NEET model so that you can get it. So सारे के सारे सेशन नोट्स आपका टेलीग्राम चैनल में मिलेगा. एवरीबॉडी ज्वाइन इन टेलीग्राम, लिंक इन चार्ट बॉक्स में आपको मिलेगा एंड डिस्क्रिप्शन बॉक्स में भी मिलेगा. एंड यू ऑल डू दिस. And in the session, my dear students, in the session you can check it. What you can check in the session? This is my class. In my class, okay. When you scroll up, you will be having a description box. In this description box, you will be having so many links. You just go through the first link, that is boost your NEET score with Infinity Learn, enroll now. So when you click this particular link, you will be directed to a page where you can see Infinity Learn by Sri Chaitanya, all the silent features and all these results, everything is given. So all India rank, NEET G Advanced goes to us, and also double your score, proven results with your NEET droppers, Ashrita, Akhil Verma, and all students' names are given. And you have also given the course they prepared to get their excellent rank. That is, these are the silent features. The comprehensive video lectures are there, and personalized learning experience is available, and detailed study materials, 33 exclusive NEET Achiever Series books, comprehensive physical material, in-depth learning comes to your doorstep, and targeted practice questions, national level mock test, performance benchmarking, efficient revision tools, expert doubt resolutions, and 24/7 ka, and unlimited practice tests. And these are the various courses that are available. When these courses you can see, my dear students, when these courses you can see, and ये courses बहुत सस्ता में मिलेगा. ये कोर्स से मेरा कोर्स कोड कितना है अन्ना मनी, मेरा कोर्स कोड एंटर करो. You just simply add buy now, and you will be directed to the page where you can enroll now by verifying your phone number, and there you are going to get my personalized coupon code. What is my personalized coupon code? It is given, my personalized coupon code. When you add this Suresh 50, you are going to get 20% of the given price. So इतना सस्ता में कोई नहीं दे सकता. My dear students, you all enroll in according to your interest, and you can do the best. Yes or no? And let us go ahead with our previous conversation, right? Yes, it is. Clear? Any doubt? Ishita? And also, this is the one we already did it, and calculation of degree of dissociation from vapor density measurements. And this is a khatarnak concept, and this is a very, very important concept, and you can do, yes, calculation of degree of dissociation from vapor pressure measurement, vapor density measurements. So the degree of dissociation is the alpha. It is the ratio of number of moles that are being dissociated upon number of moles that are taken. If alpha is equal to 1, 100% dissociation. Alpha is equal to 0.5, 50% dissociation. Agar alpha is equal to 0.1, what is the dissociation percentage? You tell me. इसमें आपका 10% होगा. So degree of dissociation is important. How it is related to the vapor density. When the gas is dissociated, its density is going to be changed. है ना? So you have to measure the density. We all know molecular weight is equal to 2 into vapor density, and this is from the stoichiometry. You can use that and you can calculate the molecular mass from the equilibrium constant, my dear students. Okay, let us say degree of dissociation can be calculated from vapor density measurements from those substances which are combined, change in the number of moles. Let us say PCl5, which is in the gaseous state, on dissociation gives rise PCl3 in the gas, Cl2 in the gas, है ना? And अगर initial moles 1 मान लो 0 and 0 होगा, अगर alpha is the degree of dissociation, 1 minus alpha and alpha होगा अविनाश. हाँ, BSc नर्सिंग का नहीं है सेशन, ये नीट प्रिपरेशन का अविनाश. Okay, and the total number of moles is going to be 1 minus alpha plus alpha plus alpha, so that you are going to be total number of moles equilibrium में 1 plus alpha होगा. Let the volume occupied by the vapor per mole is V liters. Initial vapor density is capital D, and vapor density after dissociation is a small d. How this capital D, small d and alpha is related, and that is related as the total number of moles, we know that, and it is going to be alpha is equal to D minus D upon n minus 1 into D. Let n moles are dissociated. It's simple formula. Also you can calculate the alpha is equal to theoretical minus observed molecular mass upon n minus 1 into observed molecular mass. What is this? Theoretical molecular mass MO is going to be observed molecular weight. So many important formulas that I am giving you. You don't leave these formulas. Take care of these formulas and you can do the best. है ना? And also vapor density. Immediately a concept है ना? Followed by a question. Followed by a question. Ishita, Ottam, come on. Who is going to give the answer for this question? Make it fast. Make it fast. Ha. Yes, it is. And N2O4 dissociate to gives rise NO2. You are asked to calculate abnormal molecular weight, and equilibrium constant is given as 42, and degree of dissociation is given, and you have to calculate degree of dissociation, that you need to calculate alpha and the percentage of NO2 in the mixture. From there also you can calculate. You can see for the reaction N2O4 gives rise NO2 when observed value of vapor density is 42. Okay, so it is given the vapor density at equilibrium mixture is given 42. So abnormal molecular weight is equal to 42 only, that is equal to 42 into 2, that is equal to D is equal to 2 into vapor density. So molecular weight is equal to 2 into vapor density, that is 2 into vapor density 42. And also you can theoretical molecular weight is going to be 42 into 2 is equal to theoretical molecular weight 92, 2D is equal to 92, D is equal to 92 by 2 is equal to 46. So alpha is equal to D minus D upon D is equal to 46 minus 42 divided by 42 is equal to 0.095. Okay, so I just want to say 9.5% is dissociated. It's very simple. You can do from this given awesome formula. just don't leave this formula. This formula is very important. This formula is very important. Everybody take a simple click and snapshot, you will understand this. Okay, and और क्या चीज़ है, आगे बढ़े दो. And N2O4 gives rise NO2 1 and 0 when time is equal to 0, and at equilibrium it is going to 1 minus alpha and 2 alpha. Alpha is given 0.905, it is going to be 0.19. Total moles at equilibrium, that is going to be 1 plus alpha, that is 1.095 you are going to get. And the percentage of NO2, 2 alpha upon 1 plus alpha into 100, that is 0. Rehan Rajputra, yes, 0.19 upon 1.095 into 100, that is 17.35 is the dissociation. Fine, 17.35 is the dissociation. Any doubt? Look into this. So any doubts are there, Rehan? And I have given A, B, C. So this is the C part. So any part can be asked as a question from the NEET examination. NEET examination में इतना लंबा questions नहीं आएगा, right? That's good. Now let's talk about one more question. Calculate the percentage of dissociation of H2S gas if 1 mole, 0.1 mole of H2S is kept in a 0.4 liter vessel at 900 Kelvin. वापस समझाना है क्या? ओके, ये वाला जो है ना रेहान राजपुत्रा, या ये क्वेश्चन वाला, उसमें क्या चीज चाहिए आपको, सीधा बताओ. ये पी से, यस, इसमें N2O4 इक्विलिब्रियम में देने तो N2O4 गिव्स रेस NO2. अगर मान लो अल्फा इज इक्वल डिग्री ऑफ डिसोसिएशन, सो N2O4 reversibly gives rise to NO2. So when T is equal to 0, it is going to be 1 and 0, and T is equal to equilibrium 1 minus alpha is going to be 2 alpha, because 1 mole can give 1 alpha and 2 mole can give 2 alpha, na? So that is going to be total number of moles is equal to 1 minus alpha plus 2 alpha, that is equal to total moles. That is going to be 1 plus alpha. That is going to be 1 plus alpha, है ना? That's what I mentioned here, 1 plus alpha. So in that 1 plus alpha value 0.095 हम कैलकुलेट कर चुका previous slide से, देखो 0.095. Are you getting or not? There you can say alpha evaluate percentage is equal to number of moles of NO2 is 2 alpha upon total number of moles, that is total number of moles. So that is going to be 0.19 upon 1.095 into 100. Rehan Rajpura, if any student asks a question in the chat box, the related question related to this particular topic is going to be honored like anything. So you don't have to worry, you feel free to ask in this live interactive session on the YouTube platform. Okay, and when you solve it is going to be 17.35% is going to be your answer. Fine, got it? Rehan, fine beta? Yes, thank you very much. So I like your sincerity, my dear students. I like it, because whenever in this YouTube platform, my dear students, I can see hundreds of students are coming and attending. In that, some students come and go, some students come today, day after tomorrow, they don't come again whenever they feel they are coming. And some students, when we start the classes, NEET STEP UP 2025 program, right from the May month till date, many students I can see, and I can memorize their names and memorize their nicknames also, and they're sincerely coming on YouTube platform and attending the class, and you liking the class, and I really appreciate your efforts, and I bless you. Definitely your efforts shouldn't go waste, and it should be in the positive way, and you will be getting NEET 2025 sure shot rank, and try to be a topper in that also, है ना, because you are getting this many good examples. So नीट एग्जामिनेशन जो पेपर में इससे ऊपर कुछ कॉन्सेप्ट्स के बारे में कुछ क्वेश्चन नहीं आ गया. ओके, थैंक यू वेरी मच, एंड लेट्स सी one more question. Calculate the percentage of dissociation of H2S if 1 mole of 0.1 mole of H2S is kept in 0.4 liter vessel at 900 Kelvin. The value of the reaction constant is going to be 1 into 10 power 4. That is the equation, equilibrium constant value. Now let us solve it. Again the same way, H2S is given as 0.1 and it dissociated at equilibrium 0 and 0, at equilibrium 0.1 minus 0.1x and 0.1x and 0.1x by 2, because 2, 2, 1, 1, 1 can give 1 by 2. The same logic I just want to write it. So इससे कुछ खास बात नहीं है. Okay, and directly you can take the Kc is H2 square dot S2 upon H2S whole square, but here S2 is a vapor, it is a vapor. So 0.01x by V square 0.01 by 2V upon 0.01 minus 0.01x by V whole square should be equal to 10 to the power 4, and on solving the entire by using quadratic method, x is going to be 0.02, mean to say just 2% dissociation is happening. Got it? Just 2% dissociation is happening. And this is one more model, and let's talk about Chatelier principle, and definitely you will be having 100% sure shot question from NEET examination. And you see atomic structure ऐसे मान लो आपका quantum numbers का है, and chemical bonding molecular orbital theory का है, and chemical equilibrium Chatelier principle का है. क्वेश्चन आना है बस. Yes it is. And chemistry is so easy. Why you are worried? Chemistry में आपका cent marks में आना क्या है? Definitely. So according to this principle, if you disturb the equilibrium equilibrium has a tendency to re-establish the equilibrium, because the equilibrium is always dynamic in nature. If you disturb the equilibrium, how you disturb? Go and poke it. No. You can disturb the equilibrium by change in concentration, change in pressure, change in temperature, inert gas introduction, many things you can do it. And if any disturbance is done and the equilibrium is disturbed by that time, again is going to re-establish its equilibrium. So that is what you call it as Chatelier principle. Chatelier principle is very, very important. Many industrial processes are related to this Chatelier principle, and also you can use this Chatelier principle concept in various ways, in theoretically and practically. Okay, and let's see change in the concentration. If the reactant concentration is increased, reactant concentration decrease करने का कोशिश करते हैं. कैसे? ये reaction आगे बढ़ना है. अगर product concentration is increased, so product concentration decrease करने के लिए reaction पीछे आ सकते हैं. And you can see an equilibrium increasing the concentration of the reactant result in shift of equilibrium in favor of products, while increasing the concentration of the product results in the shifting of the equilibrium in the backward direction. Let us say A plus B reversibly gives us C plus D. C plus D. So what happened? If concentration of A is increased, So the reaction is going to be favored in the forward direction. Let concentration of C is increased, the reaction is going to be favored in the backward direction. If concentration of the C is decreased, what happened? Tell me, forward, backward, chart box में देना आंसर, चार्ट बॉक्स में आंसर देना फटाफट. Okay. So if concentration of C is decreased, so C want to increase. So C can be increased by taking the reaction in the forward direction, in the more forward. Understand? Clear? Fine. And let us say one more important pattern. Change in the pressure. Change in the pressure. Change in pressure is very important. When the pressure is increased, number of gaseous moles per unit volume decreases. So it want to increase the number of moles. In number of moles per unit volume increases. So it want to decrease the number of moles. So what I mean to say, when the pressure is increased and the reaction shift in direction to decrease the number of moles, right? Yes. Forward, you don't say maybe, it should be, your answer is correct. Your answer is correct, Rehan. And if delta N for the gases reaction is 0, pressure has no influence. If delta N is equal to positive, if pressure is increased, reaction favors in the backward direction. If delta N is equal to less than 0, if pressure is increased, reaction favors in the forward direction. So this is the trick, you can get it. Simple trick. I am going to give that at the summary point. One more important, change in temperature. One more important point, change in the temperature. The change in temperature can be explained basing on the 1/2 equation. For exothermic reactions, if temperature is increased, the reaction favors in the backward direction. For endothermic reaction, if temperature is increased, the reaction favors in the forward direction. Yes, Rehan Rajpura, fine. And these A, B, C points are very important. Make a note of it. Take a snapshot. 3, 2, 1. Now, and let me talk about the tricks and the tips. Effect of pressure and effect of introduction of the inert gases. And trick number 1, effect of pressure. If delta N value for the gases reaction is 0, if delta N value for the gases reaction is greater than 0, if delta N gases reaction is less than 0. For this, if pressure is increased or pressure is decreased, has no effect. For the pressure is increased, the reaction is going to be favored in the backward direction, and for less than 0, pressure is increased, the reaction is going to be shifted towards the forward direction. And based on this, one more important point I just want to say, effect of introduction of the inert gas. Effect of introduction of the inert gas or inert material. Based on that, you can have a cracky questions, and I can say here, at constant volume that is delta V is equal to 0. At constant pressure delta P is equal to 0. Array, it's very simple. It's very simple. You can see, my dear students, has no influence at all. Has no influence at all. When you use at constant pressure, use this effect opposite to pressure effect. Apply opposite effect of pressure change. So, what to say if delta n is equal to 0, no effect. If delta n is greater than 0, if introduction of the inert gas, let us say helium, reaction favors more on the forward direction. If delta n is equal to 0, if helium gas is introduced, reaction favors in the backward direction. It's very simple, right? It's very simple, and this is the simple tricks that based on the Le Chatelier principle. And also, if the temperature effect, what is the effect of temperature of here? Yes, Abhinav, you came late, and delta H is equal to 0, thermoneutral reactions, okay, delta H is equal to greater than 0, delta H is equal to less than 0, and temperature has no effect. Temperature has no effect here. Yes, agar temperature delta H is greater than 0 means exothermic reaction. This is exothermic reaction. Endothermic reaction positive. Here it is exothermic reaction. So, for endothermic reaction, temperature favors the forward direction, and temperature increases for exothermic reaction in the backward direction. This slide can give you extraordinary answers for the questions. Yes, school के जल्दी आ गया आपको बोलने के लिए. Okay, very good. You all understood this. And any doubts as far as this Le Chatelier principle application, you just quickly let me know a simple question. Ready for the questions? Ready for these questions? And let's apply Le Chatelier principle for various questions. Let's say applications of Le Chatelier principle, formation of HI, H2 plus I2 gives rise to HI, and 300 kilocalories are released. In that, effect of concentration, you all know effect of concentration. When the concentration of H2 and I2 is increased, formation of HI is going to be increased. And also effect of pressure, as this reaction delta n is equal to 0, thus no effect of pressure is seen here. And also effect of temperature, the formation of HI is exothermic. Why? Because heat is one of the product. So that if the temperature is increased, reaction favors in the backward direction. So in short, favorable conditions for greater yield of HI, so high concentration of H2 and I2 maintain करना पड़ता, low temperature इस्तेमाल करो, and has no effect of pressure. Is very important. ठीक है? Is very important. And also formation of NO, various points, effect of concentration, of course we know it, and effect of pressure. For this you just see delta n is equal to 0, फिर भी इसका pressure का कुछ इफेक्ट नहीं होगा, एंड इफेक्ट ऑफ टेम्परेचर ये वाला -43200, so that the temperature favors in the increase in the temperatures because it is endothermic reaction. Delta H is equal to positive. Okay, this reaction you can also say N2 plus O2 plus 43200 calories gives rise to NO. You can also say na. So it is endothermic reaction. What do you say? It is an endothermic reaction, and favorable condition for a greater yield of nitric oxide is going to be high concentration of N2 plus O2, high temperature, no effect of pressure. Hey, yes, it is. Now, dissociation of PCl5. You tell me favorable conditions. Uttam and Rehan Rajpuram and Abhinav. You tell me. What are the conditions? Here, the effect of concentration, high concentration of PCl5 should be maintained. Yes, and also effect of pressure, the volume increases in the dissociation of PCl5. Delta N is equal to +1, so that if pressure is increased, reaction favors in the backward direction. Reaction favors in the backward direction. है ना? And also effect of temperature, you can say that is endothermic reaction. You can also write this reaction as PCl5 plus 150000 gives rise PCl3 plus Cl2. You can also say PCl5 gives rise PCl3 plus Cl2, delta H is equal to plus 1500. Okay. Now it is endothermic reaction. Effect of temperature, it is endothermic reaction. Temperature is increased, the reaction favors in the forward direction. So you can really enjoy with this. And favorable conditions for the PCl5 formation, high concentration of PCl5 maintain करना पड़ता है, and also low pressure and high temperature. So what not, every reaction you can maintain this Chatelier principle. Yes, it is. And also synthesis of ammonia by Haber's process, because this Haber's process of synthesis of ammonia, this Chatelier principle is mainly highlighted there. Okay, and good to see very good number of students, my dear students. Here you can see the favorable conditions for the greater yield of ammonia. It is high concentration of nitrogen, high concentration of hydrogen, high pressure and low temperature. My question is, if helium gas is introduced at equilibrium, so what is the state of equilibrium? Equilibrium आगे बढ़ना है, equilibrium पीछे आना है. Rehan Rajpura, you tell me, make it fast, you tell me. You tell me. Array we have, you can see. Use the trick, we have the trick na. Where is the trick slide? Yes, it is. Use this trick. Rehan Rajpura, use this trick. Definitely, when inert gas is introduced at constant pressure, if delta N is equal to less than 0, helium gas is introduced, it is going to be favored in the backward direction. So in the backward direction you can see at constant pressure this is the condition, reaction favors in the backward direction. Why? Because this reaction delta N is equal to minus 2. Okay. So, high concentration of N2 and H2 should be maintained. Yes, the backward, yes, it is correct, and high pressure should be maintained, and the low temperature is actually favored, but at low temperature reaction rates are less, so moderate temperatures are maintained. Okay. And also formation of SO3 from SO2 plus O2, SO2 plus O2 gives us SO3, delta H is going to be here, the high concentration of SO2 and O2, and high pressure and low temperature should be maintained again for this same reaction the same way. Okay. Now, special points I just want to give you. This is very important. Special points that are required. Irreversible reaction. So, we are done with the concepts. But I just want to introduce you some more points as far as the equilibrium is concerned. Irreversible reaction proceeds in one direction and completed with time, while the reversible reaction proceeds in both directions and never be completed. ये important है. Okay. And also equilibrium is defined as the point at which the rate of forward reaction and the rate of backward reaction are same. है ना? And also chemical equilibrium is always dynamic equilibrium and stated approaches from both sides, right? And also active mass is a molar concentration of substance, active mass of solids, and the pure liquid is taken as unity we just discussed. Solid जब आता है ना, इसका 1 लेना, pure liquid जब solvent आता है ना, इसका भी 1 लेना है. And also equilibrium constant has a definite value of every chemical reaction at a given temperature. जब तक temperature constant है, equilibrium constant भी constant है. Understand? That's very important. Only temperature can change the value of the equilibrium constant, independent on concentration and a catalyst. And we are getting yes. And also if the reaction can be expressed the sum of 2 or more reactions, then the overall Kc will be equal to the product of the equilibrium constant of the individual reaction. Ye खास बात is very important. I just want to say, example, SO2 plus of O2 gives rise SO3 and gives rise K1. This can also be written, and NO2 plus NO2 gives rise NO plus of O2 K2. SO2 plus NO2 gives rise SO3 plus NO. We want to say K is going to be sum of these two reactions. So, when the equations are summed up and the equilibrium constant is going to be multiplied, that is important. So, when the equilibrium constants are multiplied, equations should be summed up, right? And also change in temperature, pressure and concentration favors in one of the reactants, and thus the shift of the equilibrium point is in another direction. Okay. And also a catalyst enables the system to reach the state of equilibrium more quickly, but the catalyst never initiate the reaction, right? Catalyst never and ever initiate the reaction. And also the pressure volume has no effect on the reaction, in which there is no change in the number of gaseous moles. And also if the concentration of the reactant is increased and the product is removed, the reaction takes place only in the forward direction for any reaction. Okay, right. And also you can see, and the Gibbs free energy change and the rate of a reaction equilibrium constant, that is given by delta G is equal to delta G plus delta G naught plus 2.303 log Q. Q means reaction quotient, and G is equilibrium constant, and G at equilibrium, G is going to be 0, then Q is going to be K, then delta G is equal to minus 2.303 RT log K. K stands for here equilibrium constant. So we discussed so many points in today's class, and also we connected with the thermodynamics, we connected with the equilibrium. Today we had a great swell, my dear students. Rehan Rajpura, come on, are you able to find with all the concepts? Risha Sharma and Abhinav, Annamani and Ishita, that's good to see everyday attendance over here. And tomorrow we meet with hydrocarbon, most expected questions from the NEET examination, and we had a great swell in today's class, and we'll be doing great things more in the further sessions. I request you guys, please like the sessions and share this session with your friends and subscribe. Thank you very much. Signing off, Suresh from Infinity Learn. Thank you. Bye bye.